There are now we see the nature of light. There are different theories regarding the nature of light. First theory is Newton's corpuscular theory, and second theory is Huygens wave theory. This theory is based on particle nature of light, and Huygens wave theory is based on wave nature of light. There are some postulates of these theories. Now see here. According to Newton's corpuscular theory, light consists of very small particles. We call it as a tiny particles called as corpuscles. And they travels with the speed of light. Different colors of the light are due to different sizes of these corpuscles. This theory explains reflection, refraction, and rectilinear propagation of light. That is, light travels in straight line. The phenomenon is explained by the corpuscular theory, but it does not explain. This theory does not explain some phenomenon related with light, that is interference, diffraction, and polarization. Interference, diffraction, and polarization are not explained by this theory. So this is about the Newton's corpuscular theory. Scientist Newton considered the particle nature. According to Huygens wave theory of light, light travels in the form of waves. Travels in the form of waves in all directions with the speed of light. Means it travels with the speed of light. Different colors of light are due to a different wavelengths of light. See here, different colors of light are due to different wavelengths. Different wavelengths of light. In corpuscular theory, the different colors are due to different sizes of the corpuscles, but here different colors of the light are due to different wavelengths of the light. This theory explains the reflection, refraction phenomenon. Reflection, refraction, interference, explain the phenomenon, reflection, refraction, interference, diffraction, and polarization. Diffraction and polarization. These phenomenon are explained by this theory. And it does not explain photoelectric effect and Compton effect. This photoelectric and Compton effect are mainly related with particle nature. They are not related with the wave nature, and this theory is based on wave nature, so it does not explain the phenomenon such as photoelectric effect and Compton effect. So this is about the nature of light. One MCQ may be asked on these points. Read these points carefully about the Newton's corpuscular theory and Huygens wave theory. Then next important concept here is a wavefront. Types of wavefront and wavefront. So what is wavefront? Wavefront. You know about the wavefront. It is the locus of points or wavelets, locus of points called as wavelets, locus of points or wavelets having same phase of oscillation, same phase. This word is very important. Same phase of oscillation. What it means? Suppose this is the source of light. Light travels along all directions. Suppose after time t, the wave covers a distance c into t. C is the velocity of light, t is the time. If we take this S and center and radius ct and draw the spherical surface, then this each wave reaches at this point on the spherical surface. These all points have same phase. These all points have same phase or same state of oscillation. It means if crest is reached here, at every point on this surface or spherical surface, crest is reached. And this locus or set of points having the same phase of oscillation is a wavefront. This spherical surface is a wavefront. If we draw perpendicular to this wavefront, these are the perpendiculars to the wavefront, that perpendicular is a ray of light. Perpendicular to the wavefront is a ray of light. It is also called as wave normal. See here, this is the wavefront, locus of points or wavelets having the same phase of oscillation. This wavefront is a spherical wavefront. These are the rays of light. Perpendicular to the wavefront is a ray of light, and this ray of light is also called as wave normal. Depending on shape of source of light, the wavefront is of three types. The types of wavefront are depending on shape of source of light. Types of wavefront. Types of wavefront is based on shape of source of light, or it depends on the source of light. Types of wavefront depends on shape of source of light. Three types of wavefronts are there: spherical wavefront, then cylindrical wavefront, and third one is plane wavefront. Types depends on the shape of source of light. Spherical wavefront is spherical in shape. This is spherical shape. Cylindrical wavefront is cylindrical in shape, in the form of cylinder, and this plane wavefront is a plane. It is in the form of plane. Now in spherical wavefront, it emerges from point source. Emerges from point source. Important point. Spherical wavefront emerges from point source. point source of light produces the spherical wavefront. The wavefronts are concentric with point source. Wavefronts are concentric. That is having the same center. Wavefronts are concentric with point source of light. Suppose this S is a point source of light and this is the spherical wavefront. This is also a spherical wavefront. These wavefronts all are concentric with point source of light. S is a point source. And these spherical surfaces are the wavefronts. And these arrows indicates the direction of propagation of light. We call it as a wave normal. Now cylindrical wavefront is cylindrical in shape. As here it emerges from the point source of light. For spherical wavefront, a linear source is there. Source is linear source. What is meant by linear source? That is straight line source. Straight line source, like tube light. Source is a straight line source, like the tube light. The wavefronts are coaxial with source. Wavefronts are coaxial. Here wavefronts are the concentric. Here wavefronts are coaxial. That is having the same axis. Wavefronts are coaxial with source as common axis. Source as a common axis, and this wavefront is like this. Cylindrical wavefront. As time passes, the wavefront is like this in the form of these cylinders, and there is a common axis. And wavefront in the form of plane is a plane wavefront. For the plane wavefront, the main thing is source is at very large distance. That is, light reaches from the sun. From earth, sun is at very large distance. Light reaches the earth from the sun in the form of plane wavefront, and the rays are parallel here. If the source is at very large distance, the rays are parallel, and the wavefront is in the form of planes like this. We call it as a plane wavefront. These are the light. So this is about the spherical wavefront, cylindrical wavefront, plane wavefront. The main concept here is, in spherical wavefront, the amplitude of wave is inversely proportional to distance from the source, and intensity of wave is, we know it is directly proportional to a square, so it is 1 upon r square. 1 upon r square. For the cylindrical wavefront, amplitude of the wave is inversely proportional to square root of r. And intensity is as square, directly proportional to a square, so intensity is inversely proportional to r. But in case of plane wavefront, amplitude and intensity does not depend on the distance. Here it varies with the distance like this. Here it does not depend on the distance, so amplitude and intensity remains same. even if reaches from sun to earth, it remains same. So this is about the wavefront.